In this video lecture, we're going to look at the syntax for how to write conditional statements in Python. We're going to do this a little bit differently. On the left-hand screen, I've got Visual Logic, and in the right-hand window, on the right-hand side of my screen, I have got JGrasp, which is our integrated development environment. And what we're going to do is build a really basic conditional statement on the left-hand side, and then what we'll do is talk about how we might translate that into Python on the right. So the first thing I'm going to do here is in Visual Logic is I'm going to go in and I'm going to add a conditional statement. And so we're used to seeing the shape where we have a diamond, and we'll make some type of decision inside of that diamond by writing a conditional, and if that condition evaluates to true, we'll branch right. If it's false, we'll branch to the left. What I'm going to do is, to make this a little bit easier, is put a variable in here that we can use as a reference. I'll just call it I, and for right now I'm going to make it equal to 2, or assign it the value of 2. And so if we wanted, in Visual Logic, we would go ahead and we would write a conditional, something along the lines of, let's say if I equals 2, and what would happen is, because I is 2, that evaluates to true and would branch to the right. And so let's put some output in here and make sure this all fits. So the goal here is not to have to do any type of animations or anything within the video lecture, just kind of have everything right in front of us. So if I equals 2, we're going to evaluate that evaluates, I can't even spell, evaluates to true. And we'll hit OK. And note that we can get that full thing in there. Notice we're not going to have anything happening on the left-hand side of our conditional. And note that when I run this, we're going to have the output box say, hey, that's true. So let's look at how we can write this in Python. Notice we don't have anything going on the false side. We're not doing anything yet. We just have this very straightforward process. So let's move over to the right-hand side. I'm going to do the exact same thing. I'm going to set up a variable named I, and I'm going to assign I the value of 2. And what I'm going to do is then go ahead and write an if statement in Python. So let's talk a little bit about the syntax. Conditional statements in Python are often called if statements because they use the if keyword. Note in my IDE that the if keyword is highlighted purple. And what I want to do is write this exact same conditional that I've written on the left-hand side over in JGrasp. So I'm going to say if I equals 2, and I'm going to put a semicolon. A couple things to note about this line. It's going to look a little different than how we did things in Visual Logic. First of all, note that I used 2 equal signs here versus 1 equal sign here. On line 1 in Python, 1 equal sign is the assignment operator. In other words, take the value on the right, store it in the variable on the left. But when we're talking about conditional statements, which is any statement after the keyword if we want to actually compare something to something else, in Python, the way we say is equal to is by using 2 equal signs. So this is a difference from what we've seen in Visual Logic and something you'll have to get used to. So the double equal signs means equal to, and that is just something you're going to have to learn. This conditional would work properly if we only used 1 equal sign, but it wouldn't be evaluating what you think you're evaluating. So if you want to ask the question, is I equal to 2, you need to use 2 equal signs. The next thing you'll note is that we don't have this neat diamond that we have over here in Visual Logic that indicates where our condition starts and ends. What you'll note is on the right-hand side, I have I equals 2, and the way we indicate where our condition ends is we terminate this line with a colon. In Python, there are going to be a number of statements or lines that we terminate with a colon, and one of the nice things about Python is there's very minimal syntax that indicates the end of a line. For example, on line 1, notice that I can just say I equals 2, where I is assigned the value of 2, and I don't need to terminate the line. Like in a sentence, we might use a period. In Java, you might use a semicolon. But in Python, we don't need to do anything. But for my if statement, because I have a conditional statement here, the language parser needs to know where that ends, so we're going to end that line with a colon. So the next thing I'm going to do is go ahead and print a similar statement that evaluates to true. I'm using Python 3 here, so I'm going to use Python 3 syntax, which involves using parentheses around the print function arguments. And what we now have are 2 identical programs. And one of the things that's really important that we did not discuss last week in Python, but notice in Visual Logic I have this arrow that points to the branch that is considered the code related to the true part of my conditional statement. Well, the way Python groups these statements together is different than Visual Logic. Like in Visual Logic, we know we can put any number of statements or any lines of code on the right-hand side underneath these arrows as it goes down. And this kind of groups these statements. Well, how do we group statements in Python? One of the interesting things about Python is it uses space. In this case, I'm using tabs. And by tabbing over underneath the if statement, what this says is this print statement is associated with this if statement. So this tab here, this space, you don't have to use a tab. You could use spaces. I'm not going to get started on that argument. But the idea here is that anything that indents this code underneath this if statement conditional is acceptable. So let's run it, see what we get. And say, yeah, that evaluates to true. So cool. Let's put another output in here. I'll go back and have what I had. And I'm just going to write more stuff. And I want to do this because I want to emphasize the spacing issue in Python. Note that if I type more stuff, notice that I had to indent this line as well. Why? Because this basically says line 4 and line 5 are code that is related to, or lines of code that are related to this conditional statement. So if I run this, clear it, run it, what you'll note is that if I equals 2, both of these items run. Let me change the value here of I to 3. So this will no longer be true because I does not equal 2. And notice nothing prints, right? Why? Because these only print when I equals 2. You might be asking, what happens if I left out that tab? Well, what's going to happen is then only line 4 is associated with the conditional statement. Notice with I equal 3, none of these lines printed, but I now backed this line up. Line 5 is now left aligned with the left column, the leftmost part of the start of the line. And if I run it, what you'll notice, more stuff printed. And you're like, well, wait, why did more stuff print? Right? I doesn't equal 2, it's 3, so this is false. But the way this should be read is that without that indent, line 6 in this case, now that I bumped it down a line, is its own separate independent coding instruction. And so what happens here is that if I really want this line and this line to be executed only if I equals 2, I have to make sure that they have a matching level of indent directly beneath this conditional statement. So what happens if you have the spacing off by a little bit? What happens if I did something like that? Well, when I run the code, notice I get an error. And it says, hey, unindent does not match any outer indentation level. So the one thing in Python is we're going to have to learn that indents matter. How we space code on the left-hand side of our page matters. And that once we do this, we have to be consistent. So that's one of the reasons why Python, I think, is one of the many reasons why Python is a great introductory language, is that the syntax of the language actually forces some code structure on you. It requires you to be very formal in some ways in how you write your code and makes your code more readable. If you're writing a research paper, you use paragraphs and formatting to make it more readable. You don't just put everything in one big paragraph, I hope. Same thing goes with code, and Python, by nature of the language, these spaces mean something. So these two lines, now that they're indented, 4 and 5, under this conditional, are the equivalent to this statement over here. And since we've got false statements going on, let's take a look one more time at what it means if you're not indented. So now I've mirrored these two. So if I run my code on the left, nothing happens. If I run my code on the right, nothing happens. Now, before I said, well, what happens if this is not indented? Well, the code on the right would be the equivalent of writing this code. Okay? Whereas, note this indent indicates that this line of code should be underneath this conditional statement. Without the indent, it indicates that this would come after that item. Great. I'm going to actually delete the second line. You know what? Let's leave it in there. Let's pull this back up, and let's put this back where it was originally. And now what I'm going to do is go ahead and talk about what do we want to do if there's something on the left-hand side. Well, in our case, let's say just false. So I'm going to put an output over here, and instead of typing a sentence, I'm just going to say that is false. And so right now we know we have a conditional that's false because I is assigned the value of 3. So since 3 does not equal 2, we should branch down the false side. So just like we've seen in the past, and note that the output I get is that this is false. So this is correct, and we go this way. Notice that you don't need to have anything under the false branch. Same thing in Python. You don't need to have the false branch have anything in it. But how would we duplicate this in Python? Well, the way I would do this is we're going to use the else keyword. And basically what this says is, if this is true, do this. Otherwise, do this. And same thing that we did with the true conditional statement above. What we're going to do is use the indent, and notice these are all indented the same, to indicate that this line of code is associated with this else clause. So if I had 10 lines of code under here, and I only wanted those to happen when this statement up here evaluates to false, they'd all have to share the same indent. And so now if I hit run, I get this is false, just like I did over here. So that's pretty awesome. We've got a direct correlation between how we wrote if statements in visual logic with how we write statements in Python. Let's look at nested if statements next. So for nested if statements, what I'm going to do is back some of these items out. We'll still keep this default conditional here. And so what I'm going to do is change this a little bit. I'm going to say, hey, if I is greater than 0, we'll branch to the right. And if I is less than 0, we'll go to the left. And so on the right, I'm just going to put, oh, let's not put the output there yet. Let's change this a little bit. Let's put another conditional statement. So if I is greater than 0, we want to come this way. And now what we're going to say is, hey, if I equals 2, we want to print you entered 2. You entered 2. Otherwise, we'll just say greater than 0. Not 2. Yeah. So now we're going to have the statement on the left, and I'll zoom out so we can see this whole thing. Where, if the value is greater than 0, we'll go to the right. 3 is greater than 0, so we should branch this way. But 3 does not equal 2, so we'll go this way. So if we were to run this, we should get greater than 0, not 2. So let's look at how to write this statement over here in Python. So first things first, I'm going to mirror this top level conditional, I is greater than 0. So I'm going to put I is greater than 0 there. Now instead of printing anything out, right, we also note, by the way, if we look, I have nothing over here. There's no else statement. So I'm going to get rid of that. I don't need it. And now what we're going to do is look at how do we put another if statement in here. Well, notice that this conditional statement is underneath this true branch. So as we talked about before, for you to associate a specific amount of code with a specific branch of a conditional statement, it has to be indented. So if I is greater than 0, I want to go this way, and if that's true, the next thing I want to do is determine if I is equal to 2. And if it is, what I'm going to do is go ahead and put in, print, you entered 2. And you'll note that I'm using tabs, so I'm going to try to make this all line up a little easier to read. Probably a better spot to use spaces. But notice that if I didn't enter 2, I want to say greater than 0, but not 2. Well, because this else statement is associated with this if, right? I have one if statement inside of another. Right? I have the ability to say, hey, print greater than 0, not 2. And if I run this, I should get the same answer as I did over there. Right? 3 is greater than 0. It's true. So we come down here, but it's not 2. It's greater than 0. So this is how we nest if statements. Just like any other code you put underneath a conditional statement, the only thing you really need to do is pay attention to how you tab or space over your code so that you have a standard or uniform alignment of the left-hand margin. Let's come back over to my visual logic code here, and let's actually add a statement over here in the false sense, and we'll just say less than 0. So I'm going to zoom out a little bit. Might be a little hard to read in the video, but at least we get to see the full branch. So if I is greater than 0, we're going to go to the right, but if it's not, we're going to go to the left. And how would we write that now over here? Well, note that this output is associated with this outer conditional, not my inner conditional. So over here in Python, what I need to do is tab all the way out to the leftmost margin. And we can see that line 3 is associated with line 8 because they both align to the left-hand margin. And all the code under this true block of this if statement, lines 4, 5, 6, and 7, are related because they have the same leftmost margin. And so now we can put the same print statement in here and say less than 0. And so if we run this, we should get the exact same output as we got over here. I'm going to make this -3 so we can see that actually print. And we get less than 0. Why? Because, well, I is not greater than 0. So it jumps down here and prints less than 0. One other thing I want to point out in my code is there's another operator that's a little different than we've seen in Visual Logic. In Visual Logic, to do not equal to, we did this less than greater thing. So in other words, if I is equal to 0, not equal to 0, go this way. So if I make this 0, what you'll note is I is 0, I equals 0. Let's see which way this goes. You'll note in a second. Right? It says less than 0. Why? Because it's not equal to 0. Therefore, this is a false statement. This would only be true if it was any number but 0. And so it goes to the left. The point I'm trying to make here is that the not equals operator in Visual Logic looks like this. If we were to set this up in our environment for Python, the not equals operator is going to be the exclamation point followed by an equal sign. So the way we say not equal in Python is different from how we say not equal to in Visual Logic. Make sure you take a look at the reading to see any other differences in conditional operators, but the way we say equal and the way we say not equal are really the only two places where you'll note a big difference. One additional thing I'd like to call out is that Python does support Boolean logical operators. They're slightly different in some ways from Visual Logic. One thing to note is that they're going to be in Python. The syntax for the Boolean operators is going to be lowercase. So on the right hand side, you'll note I have the AND operator within my if statement, and you'll notice that it's lowercase and the syntax highlighting is made of purple, so we know that that's valid Python syntax. On the left hand side in Visual Logic, notice that the AND is capitalized. So it's going to be important that the first thing that you note is that you go ahead and make sure that this is lowercase in Python. Let's run this. And you'll note that my value is within range. So in Python, we have 3 logical operators. We have AND, we have OR, and we can run that, and that'll work as well. Value is in range because it emits one of those items. And the final operator is NOT, which is NOT. And by the way, NOT is not a unary operator, so we could say something along the lines of, sorry, NOT is a unary, not a binary operator. So what we would have to do is look at it like this. So if not I is less than or equal to 10. So let's make this 11. And if we run it, it should still be true because I is actually greater than or equal to 10, which is true. But then I use the not operator to take the inverse. I is less than or equal to 10, which makes that statement false because 11 is not less than or equal to 10. I take the inverse, which makes it true. So we have this ability to use the AND, OR, and NOT operators in Python. Visual Logic supported the exclusive OR operator, XOR, as a logical operator. Python does not.